Okay. All right, what's going on, guys? Coming out. I recognize a couple of you. You didn't Installfest. What's your name, bud? Benno? All right, cool. So the goal of this presentation is basically to teach you kind of the basics of Linux, kind of what it is, like what's different about it, and it's supposed to be a start in getting you to be able to be self-sufficient using Linux and getting help if you need help. So, um, short confession though, I was kind of pressed for time on making this, so I might have glossed over a few things. So if you have any questions, raise your hand and I'll try to cover it. Um, yeah, so first, probably look at the origins of so a brief history lesson. So Unix was created in actually early 70s by Ken Thompson and Dennis Ritchie at Bell Laboratories. And it was meant to be basically a programmer-friendly OS. So I already see some origins of there. And it was originally written on a PDP-11. It was originally written in PDP-11 assembly link. You can see in that picture right there. That's a PDP-11 that they're working on. And those things that they're typing on are actually the original terminals. We'll talk about what a terminal emulator is on Linux later, but basically they would type, and that paper actually there, it would actually print what they're typing on the paper and then return the command output on paper. So they actually had a paper copy about what they were doing. And so, excuse me. Later though, you guys, Dennis Ritchie and Michael Kernighan, created the C programming language, which is ubiquitous today. They created that actually so Unix could have portability. They basically created C and then they rewrote Unix in C so it was portable. But most importantly, Unix popularized this new philosophy in operating systems and took a different approach to it. It developed what's called the UNIX philosophy. And so there's three main principles of the UNIX philosophy that we see in Linux and its derivatives. First one is write programs that do one thing and do it well. So you can kind of think of this philosophy of modern education, right? Students, they go to school and they get a degree that's specialized in kind of one area. And so when they work in industry, you have a bunch of these students with different specialties working together on a complex project. That results in a wide variety of areas that are covered without diminished quality in each. It's not one person that kind of has a surface level understanding of each. You have many people that have a deep understanding of each. So that's kind of where that comes from, is programs that do specific things well. The next one is programs should be modular. They should work together. Not only do you have specialized things that do something well, they should be able to be chained together in such a way that you can get complex projects done. Kind of like the industry example, right? We want to be able to take those specialties and put them together to do something general. Okay. So, and you can kind of think of this in programming too, right? We write functions that do particular tasks and chain them together to do complex tasks, right? Rather than write one huge function that does everything, right? Kind of like the same thing. Okay. So the final one is programs should handle text streams because that is a universal interface. As we'll see, a lot of configuration and usages in Linux just use plain text configuration files. They send plain text as output. Not a lot of them do binary stuff, except the one programs that actually work with binary files. So these are kind of the three fundamental concepts in Unix that we'll see in Linux as well. And one more thing about that last point is that Unix and Linux use the file system a lot for inter-process communication, as we'll see. Okay. Problem is that Unix was not open source, right? It was designed to be in this laboratory usage. It's just to be used in this laboratory. Then they started having to do licensing with other organizations. So in 1983, this random neckbeard dude called Richard Stallman basically starts this project called GNU. Stands for GNU is not Unix. That's right, it's a recursive acronym, of course, which seems to be a spirit in computer science after this. He starts this project called GNU that aims to be an initiative to build a Unix-like free operating system, right? And he aims to give computer users freedom and control over their devices and software. And so he starts this organization called the Free Software Foundation. Now, in recent times, if you've been following this news, he had to step down because of political reasons. But for a long time, he was the president. It's still continuing to be run today, so you can see that online. And then, on 25th of August in 1991, 21-year-old Linus Torvalds was a computer science student at the University of Helsinki, started experimenting with a free operating system, a kernel basically, after he was frustrated with the educational licensing of Minix, Unix-like operating system that was licensed only for educational institutions. And so this is actually his host to CompOS Minix on Usenet when Linux was, this is basically when Linux was publicized first. I think that's kind of cool if you read that. Yeah. We can see that he says it won't be big or professional like GNU. GNU is supposed to be a full operating system, but Stallman didn't create the OS part yet. He created the software tools. So Linus used the GNU software tools for Linux. So if you look at the documentation for a lot of the tools that you use in Linux, you'll see like Free Software Foundation or GNU this, GNU that, because a lot of those tools were written in by Stallman or people in the GNU project. So GNU Linux was the first free open source operating system. Now, what is Linux? How many of you guys know what a kernel is? Yeah. Well, what would you say a kernel is? Yeah, it's, as you can kind of see in that diagram, it's the bridge between user programs and the hardware. Something's got to tell it how many resources it's allocated. Something's got to pass the USB interface to whatever program you want for your mouse, things like that. So that's basically all. Linux is just a kernel, right? Now, it's bundled with the GNU software, as I said before, and this combination is what we call a Linux distribution, distro, which is what like Ubuntu is. It's got GNU tools, and then it's got other stuff on top of it, like GNOME, which is a graphical environment. And that's basically what a Linux distribution is. Right. So this presentation was not meant to be a lecture, so further reading in the slides, I'll try to post them later, but I want to do some actual walkthroughs, you guys, because that's kind of what we intend to do here. Try to make that bigger. See that okay? Kind of got screens back there, so. Okay. Cool. So, we'll get started with one of the basics, terminal and the shell. So, we have these two different things, the terminal and the shell. The terminal, as I kind of described earlier, this graphical window right here is called a terminal emulator, okay? Basically what it does is it emulates that machine that we saw in that picture that actually prints out the commands and prints out what they're doing on paper. Except we don't have actual paper here, we have just text window, right? So that's called a terminal emulator because it emulates those terminals. People also call it a virtual terminal because that's technically what it is, okay? Now, the shell, I should have included a diagram, but a shell is basically the program that interfaces with the user from the OS. Somehow the user has to be able to interact with the OS to tell it which program they want to run. So that's basically what the shell does. Now a shell can be graphical or it can be command line based. Now Linux is known for its powerful command line shell. That's what we'll focus on in this, and that's probably what you'll be doing a lot of when you're working with Linux, is using the command line interface. Okay. So, yeah, so when you open the terminal emulator, the shell is the program that runs. Okay? It's the one that's displaying that prompt right there. That my username and then my host name of the machine, and the working directory which is that tilde is. We'll get to that in a bit. Okay. How many of you have had like no Linux experience, or like a very little Linux experience stuff? Okay. I just want to make sure I'm not repeating stuff you guys already know. Is this helping a little bit? Okay, cool. Okay, so now we'll kind of discuss what a command is. Right? There's a certain format that the shell expects for a command. Okay, so the format is some sort of command name, which the shell looks up, and then you can have options. You can kind of think of these as certain configurations, and they usually begin with either 1 or 2 dashes. Usually it's 1 dash if it's a short option, say like -s, for example. And then you can have actual long options, which are usually 2, so like some sort of long option like this. Kind of a pain to type. So usually there's a long option that's paired with a short option. Usually doing one or the other will do the same thing, but every program is different. But this is the kind of the general case. Okay, and then you'll have some sort of argument, like some sort of file name that you're passing to it, and things like that. Now, usually you don't have to specify options. Sometimes you don't have to specify arguments. But generally, these are the only things that you're going to be doing when you're typing a command. It's going to be some sort of flags that you can do, some sort of arguments that you can. Any questions so far about that, what I just said? Okay, move on. So generally, now that we've kind of discussed options, how do we know what commands do? Okay, someone tells you this weird command, ls or whatever. All right, I have no idea what that does. How can you find out? Okay, yeah, what's up? Yeah, man. Who knows what man pages are? Yeah? Okay. So man is a command, stands for manual. Now the really cool thing about Linux and anything Unix based is there's these things called manual pages, which are exactly what they are. They're a manual page that's offline. So they're stored on your system, so you can get help even without having to Google anything yet. Okay? So say we have this command called ls. We have no idea what it does. Okay? Print some output, but we don't really know what that does. Let's try manning it. Let's see if there's a man page. Oh, okay, there's something right there. What's that? Okay. So we see at the top, you'll see this, and then man pages have a particular format. They have the name, synopsis, and the description. The name, ls, that's the thing you type in the terminal. Oh, look at that, list directory content. Okay. So we're going to type ls. It's going to list something in some directory. You know that now. Now, how do we use that? Are there any options we can pass to it? You can see that the format in the synopsis tells us kind of how that do. Now, those square brackets that means that is optional. So that means you don't have to pass an option. You don't have to pass a file. You can if you want to. If there were no square brackets, then that means it's required. Sometimes they do angle braces, do required stuff, but usually. Okay, and then those 3 dots mean that you can pass as many of those as you want. So you can pass as many of the options as you want. You can pass as many file names as you want. You just have to make sure that options are for files. That's kind of what that means. Now, description. Okay, I wish I could see this. So I have to turn around. So yeah, list information about the files, the current directory by default, sort entries alphabetically, none of those options. Sort is identified. Here's some options. What does -a do? You can see that it has a corresponding long option with it. You could do -a Or you could do dash dash all. It will do the same thing. It will not ignore entries starting with dot. That's another thing I should say is usually if you hide files, when you want to hide files in Linux like hidden files in Windows, usually it starts with a dot. Okay, so press Q to quit the man page. Press Q to quit the man page. Let's try ls-a, see what that does. Oh, whoops. Oh, we got a lot more files now. So according to the man page, these files in our directory. Now that we passed -a, we can see all the hidden ones in the dot file. Any questions so far? Another thing you can do, if you want, you can see that the man page presents a lot of information. Scroll down, it's got all the stuff. That's a lot of stuff. There's a shorter one. See, you can see written by Richard M. Stallman, and Stallman was the guy that created the GNU project. So a lot of these have GNU writers in them. All right, so press Q, exit. Another thing that we can do that usually, not all, but most commands have is a -- help option or -h option. So usually we can do ls -- help or print. Well, it's a little more verbose than a lot of the other ones, but more descriptive. And usually there's like -h, which will do the same. Okay, in case it doesn't. But those are three things that we can try to get help. Okay. So if -h doesn't work, try -- help. If that doesn't work, look at the man page for it. That'll give you all the information you should need. Okay. Now there's another option that you can use that I don't really use. It's kind of like a different version of man. It's called info. And it's a little less nice to, but it's more like paragraph, like wiki based, like organized into section stuff. That's another option you can use, but I primarily don't use. But yeah, so man, -h or -- help and info are kind of like the big three. Okay. So now that we kind of know how to use commands, we'll move on to kind of the environment, right? So we kind of saw there's this thing called the working directory. Who knows what the working directory is? Yeah, what's a working directory? Yeah, so we have, like in Windows, you'd be in like C program files, and then you'd be like in that folder, right? When you open up the file browser, you can think of the working directory as like that. You're like in this directory right now. Now, usually, if you're running Ubuntu, your prompt will tell you what working directory you're in by your prompt. Okay, it's usually right before the $sign. Okay, now that tilde is short for your home directory. We'll kind of discuss what that is when we discuss the file system. But your home directory is kind of your user's directory. You can think of it as like on Windows, if you're on your desktop of your user, that's like your home folder. Like everything you have is in that. It's not quite the same, but you can kind of think of it that way. Okay. Now you can actually see what directory you're in, what your working directory is by using the command pwd, which stands for print working directory. Yeah. Okay. Okay. Is that better? I know, yeah. Is that better? Okay. Okay, so /home/me/Devon. Okay. So that's where my working directory is right now. Okay. Now, in Linux, every user has their own home directory, which is by default in /home/ and then whatever their username is. Okay. That's what that tilde stands for. So whenever you see that, that means you're in your home directory. Okay. Now, besides where your current working directory is, there are other other things that configure what environment you're running in. Now, I won't discuss this too much, but there's these things called environment variables that kind of configure things that your shell does. And we can look at them by typing the command env for environment. Okay. Now, there's a lot of them, as you can see. And you can see that Usually they're all uppercase. So we got like that top one, shell equals /bin/bash. So that's actually the shell that I'm using. You can have different shells. The default one is called bash, which stands for the born again shell. In the Unix days, early Unix days, there's a shell called the born shell. But when Stallman rewrote it, he called it the born again shell because it's like round 2 of the born shell, basically. Okay, so I can actually print those out with a command called echo. Okay, I can see what the value is by printing. Echo is like just printing to the screen. Okay, and I can prefix the variable I want to print out by a $sign. So if I want to print out the shell variable, I do $echo $shell. I'll print out /bin/bash. Okay. Okay, I won't get too much into that. If you have any questions, you can ask me about it. But some more about the environment is something that you should know is whenever you run the shell, so whenever you start your terminal emulator, there's a file that gets sourced, which basically the program runs that file before it executes. Okay. Now in bash, that file is called your bash rc, bash run command. Okay. Now every user should have one in their home directory. So if I do ls-a, should see that bash rc right there. Okay. Everyone see that? If you're running Linux, you should definitely try this out just so you can kind of see. Now I'm going to open that file. Okay. I haven't configured mine, so I have a lot of stock stuff. But we can see there's some stuff that kind of looks like programming stuff, right? Case something in whatever, return. We can see the comment, if not running interactively, don't do anything. We can see some environment variables getting set there, that his size and his file size. And then that sh-opt for shell option, -s, his append. That's some shell configuration stuff. Okay, we can see at the top there. Oh, that's one thing I didn't discuss about man. See how it says executed by bash (1) or non-login shells? Does anyone know what that 1 means? Okay, I'll discuss it real quick. So that 1, so man pages are actually divided into sections so you can find them. Okay, now you can actually do a man to find out about man pages. Okay, there's a lot of options as we can see. If we scroll down, we can see these section numbers right here. Executable programs or shell commands. I could probably use my mouse. Right here. Now the reason they have these is, so if we look at section 1 is executable programs or shell commands. If you look at 3, there's library calls. So what would happen if we did man printf? So we can see that it pulls up the page for printf1, printf format and print data, print argument according to format or execute according to option. This is a shell command. Now for those of you C programmers, we know that printf is a common C function. So how come I didn't pull up the C function for printf? Well, because there's 2 printfs. There's one in section 1, there's a shell command printf, and there's also a library call printf. So how do we specify which one we want to find? What if we want to find the man page for printf, for the C function? By the way, that's another cool thing is all the C functions have man pages. So if you're programming in C on Linux, you have offline documentation right there. It's pretty cool. I use it all the time. Anyway, the way to do that is you do man and then the section number and then what you want. So in this case, we'll do man3 printf because we know that 3 is the section number for library commands. Look at that, printf3. We got all the printf family of functions and all this header declarations for printf and all that stuff. So cool. That's another way to use man pages is specify the section number. Okay. Now I'll try to go back to. First of all, does anyone have any questions on any of that? Yeah. Yeah, I was just about to go back to that. Okay, so now let's do an ls-a again. Okay, we see a couple of these bash files. Okay, we have bash rc, bash logout, bash history. What are all these files? Okay, now bash rc is the default one. That file gets ran every time the shell opens. Okay, now there's a couple types of shells. There's a login shell and an interactive shell. And there's some other types too, but those are the kind of main ones. A login shell, I wonder if I could do this on here. Okay. So if you don't have a graphical interface on Linux, like if you ran Arch or Gentoo or some other distribution that doesn't have a graphical environment, this is what you'd get at your login screen. And I'm sorry I can't make that bigger because it's not a graphical environment. I apologize. But if you can see, I'll try to read that. Got my distribution name at the top and then dev t495 login. Okay. Now this is the login program running. So I'll type my username and my password. Okay. And I get a prompt. Okay. Now this shell is a login shell because right after I logged in, the shell appeared. Okay. Now there's a file called, I don't have it on here, but it's called .bash_profile. Now that runs only right after you log in. So if you want something to start right after you log in, you'd put it in that file. But bash rc runs every time a shell is started. So that includes login shell. So right after I log in, and I'll just log out of here, and whenever I start a terminal and start a shell, that file gets run. Okay. So bash rc is where you'd put something that you want every time a shell runs. Like say I'm trying to think of an example. Say you wanted some sort of, say you wanted the SSH daemon to start every time you logged in so that you could just, all your SSH keys would be added so you don't have to type in the password every time you want to log in somewhere, okay? You could put that in bash profile because that starts the daemon after you log in. You don't want to start a bunch of daemon programs. You don't want to start a bunch of SSH programs. You just want to start one. So you put that in the bash profile to start on login. Whereas something like setting an environment variable for just that session, you put that in your bash rc because you want it to run every time you start a shell. Does that kind of make sense? And that would be, like if you wanted, you can actually customize your prompt with certain environment variables. You'd put that in your bash rc because you want your prompt to change every time you start the shell. Because environment variables are, they're kind of local to the process of the shell. You can make them global to all processes, but usually when you just say this equals this, it's just for that current shell session, if that makes sense. There's a way to make it global, but when you make it global, it's only for shell sessions that start after that one. But the cool thing about Linux is there's many ways to do things. So there's not one way to do it, right? So if I want to set an environment variable for everything, I could put it in my bash rc and just have this equals that, or I could put it in bash profile and say export this equals that. That way, all shells that start after I log in will have that environment variable set. Okay, so that's kind of two ways of doing one thing. If that makes sense, right? There's not one way to do it. Does that make sense? I think I use some terms that may not be familiar with you guys. Do you have any questions on any of those? Do you have a question? Okay. Cool. So one more file is that bash history file. So say, I typed in a long command, ls-al. I know that's so long, right? Okay, I did that. I did, printed out my working directory. Okay. Now I want to do that ls-al again. Oh, I got to type this long command again and do that. I don't want to type in that command every time. Well, the good news is you don't have to. If you type it before, it actually gets stored in that .bash history file. Okay, so you can actually hit the up arrow. There's the command I just typed I want to go to the one before that. I type the up arrow again. There's the one before that. Type the up arrow again. There's the one before that. So you can actually go up through your history. Look, there's all the man ones. There's env. You can actually go up through your history and find commands that you typed before, so you don't have to type them each time. When you get to more complex commands, this is very useful. Now, I just lost my train of thought. There's a command, actually, you can see your history. It's just called history, appropriately. Okay, and you can see that kind of the bottom one is the most recent one. See, I just typed history, and it stored that. And then you can see other ones I typed in before that. Now, say you ask, why is this useful? Well, what if there's a really long command that I typed a long time ago, and I don't want to keep hitting the up arrow to go back to it, right? You can actually, the reason why those numbers are there are so you can go directly to that command. So say I wanted to execute one of those jobs ones, like 1806 up there. I could just do exclamation point 1806. And well, first it tells me which command it's executing, jobs. Jobs doesn't have any output, so it didn't output anything. But I just executed jobs, which is like way in the past. There's also a shorthand instead of doing the up arrow. So say you Linux users out there, sometimes you type in a command that requires a long command that requires sudo, and it says, oh, you forget the sudo, and it says permission denied. I gotta go up, and I gotta do the arrow key all the way back to the beginning of the line and type sudo. You know, like apt-update. Okay. Oh, permission denied. Now I gotta do up arrow, go all the way back here, sudo apt-update. Sudo apt-update. You don't even have to do that, okay? There's also another shortcut for doing the command you did right before that, okay? So say I did apt-update, gave me the permission error. To put in the previous command, you can do exclamation point, exclamation point. This is a direct replacement of the last one. So I could do sudo exclamation point, exclamation point. We can see that it tells me which command that it's executing. It's sudo and then this thing that I did before. Okay, so it's a direct replacement. So that's very useful if you want to. I think the most use that this gets is for this purpose right here, is the sudo thing. So sudo bang bang, sudo, it'll do sudo and then the command right before this one. Okay. Does that make sense to everybody? All right, don't be afraid to speak up if something doesn't make sense. Okay. Okay, so that's kind of concludes my section on the environment. If there's anything that anyone else has that I might have glossed over, feel free to speak up. But if not, we're going to move on to kind of the file system. Okay. So, how many of you are familiar with Linux's file system? Like how it works, or like what the structure is? Awesome. I'll kind of discuss it right here. So, who's familiar with the Windows file system, like how that's structured? Yeah? How would you describe like how it's structured? Like how would you move around places? I got the C drive and yeah, got a GUI, definitely. Yeah, so Windows, it kind of, can I do this? Oh, that's going to be very delayed. They have different kind of roots. So like this, like the C drive, which is like your main hard drive, and then like the folders off of that, and they have like a D drive if you insert a disk, like these kind of different points. Now Linux, there's one point, okay, and it's called the root directory. You might have heard this term before. It's symbolized by just a slash. Oh, that's pretty long. Okay, just a slash, okay. Bear with me, this is like really laggy, so I'm gonna drop the best that I can. And under that, there's different, I have like my notes up here. There's different directories like bin, gosh, that's terrible. etc, so etc, and like home. Okay, pardon my bad handwriting. Okay, so bin, so /bin, that's an absolute file path from the root to the bin directory. Okay, so I'm just gonna pull up my terminal here. Can I do that from here? Okay, cool. I'm gonna do ls/. Okay, we see all of these folders. So we can see some of the ones that I mentioned here. So bin, etc, home, and underneath. Okay, so everything, if you're doing, like, in Windows, you always, if you're doing an absolute file path, C:/, / program files, / whatever, everything begins with / in Linux. Okay, if you're doing an absolute file path. Okay, so I can do ls/bin. A lot of stuff in there. /bin is stores programs, right? We can see bash is up there. We can see ls is right there. I've been using ls, things like that. So yeah, this is how it's structured. And then of course we have other stuff that goes off of that. So like etc is kind of that's where all of the configuration files are for system programs. So we could have, so hypothetically, if etc had like, if ls had like configuration files, it'd be something like /etc/ls, something like that, right? So we can use that. So like, I don't know, let's see what's in etc. Bunch of stuff that's probably complicated. Yeah, yeah. So you kind of get the idea. It's a tree format, and / is the delimiter, right? And you can see that pretty much everything is lowercase, which is a Unix thing. Some of the newer programs have capital stuff, but you'll see a lot of stuff is short and lowercase, so it's easy to type, and it doesn't take up a lot of space. Okay. So, yeah. What's also cool, so let's talk about the working directory real quick. We know that we're in /home/Devon, right? How do we, does that mean that, oh, if I want to, what's in here? Well, if I wanted to look at the Git folder, does that mean I have to do ls home Devon Git all the time? Or ls /Git? Remember that tilde is replacement for your home directory. That'll do it. You can also have relative file paths. So if you're in a working directory, you can type just ls git without any slashes. If you don't begin the file path with a slash, that means it's a relative path. That means it's not starting from the root directory. So I can just do ls git. Okay. And I will list all the files in there. I'll say I wanted to see if there's any other home directories from here. Now I could do /ls/home. Turns out I'm the only one. I can also go from my home directory back up. The way to do that is by using 2 dots. So ls ... It's Devon. Now, the reason why it's 2 dots is because ls dot is your current directory. Okay. So if I did ls dot, that's all the stuff in my home directory. Okay. Now, you can use these. So if you'll notice when you do ls-a, you can see that there's dot and double dot up there. ls-a. So those are actual like directories that ls recognizes, right? Dot is the current one, and 2 dots is the one above it. Now the reason why this is because if we look at ls-l, so if you're in the man pages and you want to search, you can type / and we can type in the search term down here. So let's type in -l. Oops. -l. Okay. We don't want that one. So to go to the next one, we type in lowercase n. Okay. Do it again. And to go back, you can use uppercase n. So lowercase n. No. 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 Nope. Nope. There we go. So -l. Use a long listed format. Okay. So quit the man page. ls-l. Okay. Oh, but we want hidden files too. So we'll add the -a option. Now you can do ls-l space -a. That's a little finicky to type. So you can actually combine them into one. You can do ls-la. Okay, and I'll do the same thing. Okay, now we have the hidden files too. So if we scroll up a little bit, a lot, I guess, we can see that. Oh, I guess I should probably show you how to read this. Okay. So the first column are file permissions. Okay. I just realized I didn't include these on my notes, so I'll just kind of discuss them right now. So you can see some letters and some dashes for each of these files. What do those mean? Well, the first dash, or the first, I guess, subcolumn, that's going to be the type of file that it is. We can see there's some D, there's some L, and there's a dash. Okay. So dash, this means it's a regular file, so a text file, binary file. D means it's a directory. You can see that the directories are in blue. So those are my folders. Folders and directories are synonymous in Linux. Okay. Now, there's a group of 3 of them right after that. I guess I could use my mouse. It's probably easier for all of you to see. Okay. So I got that, the first one, and then we have this group of 3, RWX. Okay. You can see some of them kind of repeat. Okay. So this first column of 3, I guess subcolumn of 3, these are the permissions of the user that owns the file. Okay. Now, who owns the file? That would be this column right here. We can see there's 2 Devons right here. Okay. The first one is the owner of the file. The second one is the group owner of the file. Now, the group owner, say you have a bunch of files that you want to let other people, only a certain group of people access, but not anyone outside of that. How would you do that if you just had a user that owns the file? Well, you'd use a group. You'd create a group, and you'd add the users to the group, and then you'd give the permissions for the file to that group. That's basically why there's groups in Linux, okay? But this set of 3 right here that's highlighted, these are the owner's permissions. So R is read, W is write, and X is execute. Now, execute can mean a couple of different things. With directories, I believe you can see the files in the, it's either you can, I think it either means you can see the files in that directory, or you can change your working directory to that directory. I can't remember which one it is. But for a regular file, that means you can execute it like as a script or a program. Okay. The second column of 3 right here, these are the group permissions. Okay. So I'm a member of group Devon. So anyone that's in group Devon can read, write, and execute that directory, the directory git. Okay. Now, the last 3 are anyone else. Okay. So anyone that's not in, that's not owner Devon or is not in group Devon, they can only read and they can only execute in that directory. So that means they can't write anything in that directory, they can't delete anything in that directory, things like that. Okay. Does that make sense? Okay. And then that next column, I believe, is the size. No, this column is the size right here. I should probably point that out on. right here. Now directories are a bit different. Since directories are represented as actual files in Linux, you can see all of them are 4,096 bytes. They're not all the same size, but ls is just reading the actual file directory. There's a way to read the actual size of the file of the directory using the du command, which stands for disk usage, and I'll show you that right after I get finished explaining this. Okay. I can't remember. Brindra, do you know what this column is? The numbers? Can't remember. Yeah, it's really blank. It probably says in the man page somewhere under the long format. But for time's sake, I won't look. And then the date that the file was created, and the time that it was created, and then the name of the file, of course. Okay. We can see, what's this thing right here? Does anyone know what this file is right here? Number of hard links. Interesting. Okay. Does anyone know what this file is right here? This .face.icon. It's got like an arrow thing right here. Well, that is called, I'll give you a hint right here. See that, what type of file is it? It's L. That stands for link, okay? Now you can kind of think of links as shortcuts in Windows, except the implementation is different. So there's soft links and hard links. Soft links are more like what you find on like shortcuts in Windows. Hard links are you can think of them almost as copies of the file. Most often you'll use soft links. Okay, so this .face.icon is basically a shortcut to this .face file, which is right above it. So that means if I were to try to open .face.icon, it would actually open .face, kind of like a shortcut would do, if that makes sense. Yeah, I won't expand on. There's a lot to links. I won't get into that in this presentation, but if you have any questions, I'd be more than happy to answer them. Okay, so one important thing is, oh, I was going to show you du. Okay, so du, and then I'm going to make it a summary and human readable of the Git folder. And it's 115 megabytes. So unfortunately, ls won't show you the actual size of directories. But if you use the du command, and then if you look at the man page, s is summary and h is human readable, because otherwise it'll just do bytes, which would be like a huge number. It'll show you the size in a convenient format. So, and you can pass multiple files too. So that's how you find the size of like a directory. Okay. One other thing is Linux doesn't use file extensions like Windows does. So it doesn't matter how you end your file, .txt, whatever. Linux doesn't care. .exe, yeah. Well, Linux can't run exes, but unless you use wine. Yeah. So I could create a file. Hello. I'll save it as hello.exe. Okay. Well, if I open that same file in if I pass that file to cat, which prints out the contents of a file to the terminal. So hello. Oh, I guess I should mention type completion. So say hello.exe. That's kind of a long thing to type. I don't want to type that every time. You can use what's called tab completion that Bash offers. Okay? So if I start typing HE, I hit tab, it'll complete it for me because there's no other files that start with HE except this one in the current directory. So if I had another file that was like heh.exe and I typed HE and pressed tab, it wouldn't do anything because I need to somehow differentiate the two. So if I typed in HEL, now it knows, okay, it doesn't mean HEH. I'm going to complete hello.exe for him. Okay, so that's kind of tab completion, which is very useful when you're typing in names of long files, right? You can just type in a couple characters and hit tab, and it'll complete it for you. So if I cat that, it doesn't care that it's an exe file. It just prints it out for me. If I try to edit it or try to edit it in Nano, it doesn't care. Oh, I don't have. I guess I need to type it right actually. It doesn't care. It just opens it up and allows me to edit it, right? So now some programs care what file extension it is, depending on what program it is, but Linux itself does not care what file extension you're using. Yeah. Well, that's only if you're opening it in something that if you're using Vim or some sort of IDE that uses syntax highlighting. Usually it goes by the file extension. But if you're compiling it with GCC, it doesn't care what. What were you using? Were you just using GCC or? Well, let's try it. Okay. I'm gonna delete this. Hello. So test.c, or I guess test. All right. Include nonsense. Oh, I need to actually write a proper C function. See, now Vim won't recognize that the indentation because it uses the file extension .c, but that's because of the program Vim. That's not because of Linux itself. If that makes sense. So I'll just do printf, I guess. What's test? Yeah. Okay. It doesn't recognize my stuff. Now, if I just do GCC test, it should just do a.out. File not recognized. Okay. Yeah. So I guess GCC actually uses the file extension .c, which would be a GCC thing. So that would be the case. So if I just do, so I'm going to rename this. The way to rename things in Linux is mv moves files. But if you just type in move the old file name and then the new one, it's the equivalent of you're just moving it to a different file name in the same directory. So it's just the equivalent of renaming it. So if I do that now and do gcc test.c, it should recognize it. Yeah. Then a.out. Okay. Yeah. So like I said, some programs do care what extension you use, like GCC and Vim if you want it to use indentation and recognize the file. But Linux itself doesn't. Like if you were to write a script, like a shell script, I guess I'll just do that right now. Script. So usually ends in .sh, right? This line right here tells Linux to run the file with bash. It's not important. We're gonna try to do a shell scripting workshop later, so don't worry about this right now. Echo test. Okay. I need to tell the file to be executable. So change mode, add the executable option, script. Okay. Now when I run that, it just does it. Okay. But if I were to get rid of this sh, so move just a script, and I try to do that again, it'll still run it. It doesn't care what the extension is. Okay. Does that make sense to everybody? I had to do some new things just to explain this concept, but don't worry about that. We'll be doing Professor Berger wants to hold a shell scripting workshop later, which we'll get into all this stuff and how to do that. But I just wanted to demonstrate that Linux doesn't, when you're trying to run something in Linux, it doesn't care about the file extension. Okay. So yeah, I kind of introduced some new commands there. So we already went over ls. Now you can actually change your working directory with the cd command. So say I just wanted to go up, I want to change my directory to the one level up. So do cd ... Now you can see that my working directory has changed to /home. Okay, so if I ls that, you can see it's just my Devon directory right there. Okay, so I can cd into that Devon and do that. You can also use absolute paths too. So I just did a relative path with the ... but you can do like cd home Devon. You can even use the tilde. So if I wanted to go up one from, like say I was in root. Okay, say I was in some weird spot that I didn't know. Oops. Yeah. I didn't really know where I was. Okay. To get back home, you can either do cd tilde, also do cd /home/ wherever your home directory is. In modern version of Linux, you can just do cd without any arguments, and it will return to your home directory. So that's easy to remember. Just cd enter. Okay. Now I created some files in the past couple demonstrations. So how do we create files from the command line? Well, if you want to create a blank file that doesn't have anything in it, there's a command called touch. Now touch was originally designed to just update the modification time on files. So it'll do that if the file already exists. Otherwise, if it doesn't exist, it'll just create it for you. So let's just create a test file. Okay. If we do ls, we got test file right there. Okay. If we try to print the contents of that file, it doesn't have anything in it. It just creates a blank file. Okay. So now you can actually make directories too. So the way to do that is mk for make dir. Make dir is what people say. Make a test dir. Test dir. If we ls that, now we got a blue test dir right there. So that's a new directory without anything in it. Okay, there's nothing in there. So we can remove stuff too. So we can remove the test file. If we ls that, test file isn't there anymore. We can do the same with directories with the rm command, but we have to specify rm-r for recursive. Okay? That means that it goes into the directory and deletes everything that's in the directory and then deletes the directory. It'll warn you if you try to do rm without anything. Like if I try to do rm, I don't know if I want to do it with any one of these. Let me copy one real quick. So that's another thing. You can copy stuff. I don't know if you need -r for this. T-get for test. Yeah, so see, it tells me to use -r for copying directories. I need to do -r. Okay. Now, if I try to do rm t-get, see, it says it's a directory, so I can't remove it. So I have to do rm-r t-get. Now, with files that we normally don't have or have different permissions for, it'll ask us if we want to remove every single file. Okay, and we don't want to do this. Okay, and by the way, if you want to interrupt a command, if it's like running and you don't want it to finish, you can type Control-C. That'll send it the keyboard interrupt signal, which will just stop it from running, which is what I did here. Okay. So I can tell it, if we look at the man page for RM, there's that -F, that force option. Ignore non-existent files and arguments, never prompt. That's exactly what I want, right? Okay. So RM-RF, for recursive and force, don't prompt me, tget. I do ls, tget is not there anymore. Okay. All right, now there is a command, I'm not sure why it's there, but there is a command called rmdir. but that is only for removing empty directories. So this will work on tester. So if I type in tester, it'll happily remove it. But if I try to do that on my Git directory, failed to remove directory not empty. So if you want to catch all, use rm-r or rm-rf, depending on your needs. But if you want to remove only empty directories, you can use rm-dir. Okay, does that make sense to everybody? Okay, and then we already saw CP, right? I just copied Git to tget. And I was just reminded of something else that's useful in Bash. It's called reverse search. So say I typed in that CP command a long time ago, that specific cp-r git tget. I couldn't remember what exactly it was, but I remember I typed it a while ago. And I wanted to type that again. You know, we know that we have that history file that we can search through a lot. But that would take a long time. So something you can do is it's called a reverse search. So if we hit Control-R, you can see it has reverse iSearch. Okay. If I start typing CP, you can see it populates with the command I typed, because if you look searching reverse in the history, that's the first one it finds. Okay. Now say it was the one above it I wanted. I could hit Control-R again. It will go up to the next result that it finds. So the next result that it finds is that, I guess I should use my, so this is the first one that it did. And I hit Control-R again, and now we see this one. Okay. So now that we have the one we want, we can hit Control-E for edit. So if that's the one we want to do exactly, we can just hit Enter, and it will execute that command. Otherwise, we can hit Control-E, and we'll put that in a prompt for us so we can edit the command how we want to. Okay, so I can edit this and hit Enter if I wanted to, but I don't want to copy that again, so I'm just going to Control-C to clear everything from here. Okay. Does reverse search make sense to everybody? Cool. And then I already demonstrated MV. MV is just like CP, except it doesn't copy it, it moves it. Now when you want to remove files, you can do... Does everyone know how to rename files with MV? I showed it before, but it was kind of quick. Does anyone need me to go over that? Okay. It's pretty simple. You just do MV, old file name, new file name. Nothing too complicated. Okay. Okay, so now we'll move on from the file system. That was a lot. And how do we chain commands? If I want to do, like, you know, for Ubuntu users, sudo apt-update and sudo apt-upgrade right after that. How would I do that instead of typing one, hitting Enter, waiting for that to finish, and then typing another one again, and Enter? How would I do that? Does anyone know how to do that? Yeah. So there's a couple ways to do it, actually. Ampersand is one of them. So we'll just do that right here. Sudo apt-update. Update and sudo, I guess ampersand is the correct terminology, apt-upgrade. It'll prompt me for my password, and then it'll do both of them. I'm not sure if the internet is adequate here. So updating, probably should have used a smaller example for this. But so what ampersand actually does is it executes the first command, and then if that returns a 0 exit status, which means that it finished without errors, then it'll execute the next one. Okay. So now it's saying, so now we can see the output. This is apt-upgrade right here, so we know that it worked. I don't want to update right now. Okay. So if I do echo, actually no. So you can actually do return in the shell. So return 0. Oh, maybe not. All right. So one way to look at the what exit status it returns is you can echo a special bash variable called question mark. Okay, and that which returned 1 because there was an error. But if I did echo like 0, I guess ls, and I did echo this, it's 0 because it returned without error. So ampersand ampersand examines that and says, oh, did this return 0? Oh, it did? Execute this next one. Otherwise, it won't execute. So if I did that, if I mistyped like that echo command like I did, and I did ampersand ampersand echo success, it doesn't, it prints out that error and then it doesn't execute, right? So what if we wanted the second command to execute even if the first command errored out? The way to do this is by using semicolon, because basically a semicolon is just like if you program in C, it's just execute this statement, then execute the next one. So if I do this, it prints out the error, and you can see it echoes out success as well. Okay. Now there's actually a way to execute the second command only if the first command errors. Right? It's like if you wanted to print an error statement besides this one, you know, only print it if it errors out. You can do this with instead of ampersand ampersand, pipe pipe. Okay, so I do this. We can see it has the same output. It errors and then it prints. But what if I type this echo command correctly? Go test. It only prints out test, right? So it prints out test. That occurs correctly. Pipe pipe. It didn't error, so it doesn't do the second one. Okay. Does that make sense to everybody? So we got ampersand ampersand. Only do the second one if the first one is successful. Pipe pipe. Only do the second one if the first one fails. And semicolon. Do it no matter what. Okay. Okay. Let's move on to file redirection. I only got a couple more of these, so bear with me here. Let me something real quick. All right. So that's kind of chaining commands. Does anyone have any question on like chaining commands like that? You can do as many of those as you want, actually. Something ampersand ampersand this, ampersand ampersand that, pipe pipe that. You know, it's endless. Okay. Okay. So file redirection. Say you have this long file of stuff you want to pass commands, but you don't want to type them in the command line. Hold on a sec. There's 3 files that are important. One of them is standard input, standard output, and standard error. Okay. Now standard input by default is you typing at the terminal. Okay. And you hit enter, that's standard input. Standard output is the stuff that we see in like the success right here. I echoed that, echo success. It prints that to standard output. Standard error is like a stream that errors are printed to. Now by default, it's the same as standard out, so that's why we see the errors here. But we can actually redirect those. Okay, I'll get to that later. Okay, so say we had, so I'll use cat as an example, but say we have, well, let's look at the man page for cat. So catenate files and print on the standard output. Okay, so if we cat, let's see what files we got in here. Netlogs.txt. All right. So usually we cat, and then we pass it the file, and .txt. It prints it out for us. Another way we can do that is cat will accept things from standard input. Think of a better example than cat. Okay. So if we Okay. So we can see that this right here with no, if file is not passed, or when file is dash, read from standard input. Okay. So what if I did cat dash? It hangs. If I type stuff, hit enter. It repeats it back to me because I'm typing on standard input. I hit enter. It prints that same standard input on standard output. Okay. So what if I want to use? What if I want to do a file? So I could actually do this left brace and then the file name, so netlogs.txt. And what this does is, okay, instead of having to type what I want to the command, it just basically passes the entire contents of the files to it. So if I hit enter, it prints out the entire contents of the file again. Okay. Now we can do the same thing with redirecting output. So instead of cat netlogs.txt to the terminal, what if we wanted to save that output to a file? Well, so we remember how we did cat netlogs.txt and it printed out to the terminal. We can do right brace bracket, however you want to say it, Devon, and we can echo that to new file. Okay, and it doesn't print anything out on the terminal anymore because we directed standard output from the terminal to that file. So now if we cat new file, it's the exact same contents as netlogs. Okay. So I'm just going to remove new file right now, real quick. Now, as I mentioned earlier, we could do the same thing with standard error. So I think that is on standard error. Let me see. Now, say we mistyped that echo command again, right? And it prints out this error. What if we wanted to save errors to a file? Could we do this? Do you think this would work? Let's find out. So it printed out to the screen, so I'm wondering why. And then cat error. Oh, there's nothing in there. So that means we didn't actually redirect it properly. Okay. How do we redirect errors then? How do we redirect standard error? Well, the way you do that is by default, the standard input, standard output, and standard error are numbered. So standard input is 0, standard output is 1, and standard error is 2. Okay. So we can actually redirect those by using their file descriptor number, which is that number. Okay. So if we do 2 here, so this is saying redirect standard error to that file. Okay. Standard error to the file ERR. Okay. Now nothing's on the output. If we cat error, now we have the error captured in that file. That's pretty cool. Now we can actually redirect file descriptors to other file descriptors. So we can redirect standard error to standard output. So if I remove this error file, and then I try to do that command again, except 2, and so the way to do that is instead of passing this file right here, I could do ampersand and then the number of the file descriptor I want. So ampersand 1. So this says, let me do my here. Redirect file descriptor 2, which is standard error, to file descriptor 1, which is standard output. Now, we won't notice any difference except it printing out to the screen because standard output is just the screen, right? But we now redirect. I remember if it's before or after, we'll see. So now, if we redirect this regularly to a file. So yes, output. Now we don't get any errors on the screen. And if we cat output, we get the error. So basically what we did here is we say, let me just use my mouse again, sorry. Redirect standard output to output, but redirect standard error standard output. So now both regular output and errors are on standard output. So we can redirect everything to one file. So it's kind of like a funnel. We just redirected standard error and standard output to standard output and passed that to a file. If that makes sense. Does that make sense to everybody? Kinda? It's a little weird syntax, but yeah. We'll probably go over this more during the shell scripting workshop. So keep an eye out for that, definitely. There are a couple of other things that are useful, and those are, so you'll notice that if I echo something to a test file. Oh, that something has a test file in it. Oops. Oh, test file. Got that something in it. If I try to echo again, and I cat out that file, oh no, it replaced it. How do we append a file? Well, that's easy. We use 2 chevrons. This means don't overwrite, just append. I can say yet another thing. Now if I cat the file again, another thing, yet another thing. So that's how you append. Another thing is, so this is a little weird, and you may be wondering why can you do this, but there's this construct called here documents, okay? And here documents, the primary purpose is to feed an interactive program like cat, a command list or a multi-line input from the command line. So instead of passing it a file which has multiple lines, you pass it stuff from the command line that has multiple lines. Let me just show you how this works, okay? So we have cat. So if you just do cat regular, it waits for standard input, right? And you type in standard input, hit enter, and it redirects it right back to you, right? What if we wanted, instead of one line each time, we wanted multiple lines each time? Well, we could use a here document for that. So we could do cat, and then double input chevrons, and then the delimiter to know when to stop. So usually I just type stop, stop here, whatever. Okay. And you'll see why this is needed. So we hit enter, it gives us another prompt. So line 1, hit enter again, another prompt, line 2, then 2, I guess. Cool. Okay. How do we know when to stop? Well, we type that stop here. So now when we hit enter, we can see it printed all of those lines all at once, right? So you can think of a here document as giving a program multiple lines of input rather than just one line. That makes sense. You guys will probably not use this too often, but I just wanted to make you aware, because usually people ask, oh, there's a double output. There's that append thing that has 2 chevrons. Is there one with 2 chevrons going the other way? And this is the answer to that. So, okay, that concludes that section. Just a couple more things. We mentioned standard input and standard output with files, right? Redirecting to files. You can actually redirect input and output to separate commands too. Now, usually, an iconic example of this is passing some sort of output and searching that output, right? So I showed you, so if we type in like less netlogs.txt, open that in this program called less, this lets me scroll through the output, right? I'm using my arrow keys right now. Instead of just catting it to the screen and you gotta scroll your terminal, you can just put it into less. Okay. You can search, right? If I hit that / and say like my search term like device, and hit enter, it'll highlight them for me and I can scroll through them. Now, if I wanted to filter lines like that, what I could do is, so I want to echo the file, or I guess print the contents of the file, right? But instead of printing it to the terminal, I'm going to pipe it to this program called grep. Okay. Now grep, I'll look at the main page for grep, but grep is a search program, right? Okay. And I'll just type in my search term for it. I'll just type device right here. Okay. So basically what this does is redirect standard output from this program to standard input of this program. Instead of going to the terminal, go to this program. So if I hit enter, we see that we only get lines with device in them, right? So that's a way to search through files. Now, all right, I have all this crap on my terminal. How do I get it into like a file or like a pager or something, like less? Well, I just add another pipe to less. Now I have all of the search terms in something I can scroll through. Okay. Or instead of piping it to less, I could just redirect it to a file called results. If I less results, now I have all of my search results saved into a file that I could give to someone else, right? So we can kind of see the UNIX philosophy here. We have programs that do simple things chained together to do complex things, right? We have a program that all it does is output files, mix that with a search program, mix that with something that displays results nicely, or redirect it into a file. So that's kind of the whole philosophy behind Unix right there. Okay? Does anyone have any questions on all that stuff that I just described about piping? As we can see, we can mix redirecting to different programs with redirecting to different files. Okay, second last thing, I promise, are processes, okay? So sooner or later, you're going to have a process that causes a problem on your system, and you're going to want to know how to fix it. Okay, so I mentioned that Control-C sends a keyboard interrupt to something that may be running, like cat. All right, let's let cat run and hit enter all the time. Just won't stop. So I hit Control-C, send it the keyboard interrupt, and usually programs will stop if you give it the keyboard interrupt. But how do we manage processes, basically? So processes are basically just running programs. That's all a process is, okay? Every process has it's called a PID, a process ID, okay? Now, if I do PS, this lists all of my users running processes, okay? I only have bash, which is the shell that I'm using, right? And then I just ran PS from that. So it displays PS. Now we can see in this leftmost column, got a process ID right here. 4016, 5832, right? And this is the time it takes to, how long it's been running. I'm not sure why bash is 0. But, and then TTY, don't really have to worry about that. That's kind of like which terminal it's running on, but you won't really need that. Now we can actually, if we look at the man page for PS, you can actually see that. Right one? Yeah, okay. You can see that we can actually list every process of the system right here by using a couple of these options. So we did like PS-EF, we'll get a lot more. And we can see that a lot of these are running by the root user. Now the root user, I probably should have discussed that. That's a really important thing. The root user is basically the administrator on the system. They're basically like God on the system, right? They can ignore the permissions that you've set, and they can basically bypass those, right? Now the reason for a root user is, obviously to mitigate permissions, but a lot of them are operating system stuff that's important. So these are all the processes that are running on my system right now. There's a lot of them, right? And they all have a process ID, right? So, and all of them stem from PID 1 right here, which is it's called the init process, but I won't get into that. Back to useful stuff, okay? So let's say let's say for some reason I wanted to do something that was going to take a long time, and I didn't want it taking up my terminal, right? You can fork it to the background. So say I'll run that cat command. I put an ampersand at the end of it. You can do a space too, and that will fork it to the background. See, I got my prompt back. I can type stuff, but you can see that it gave me this process ID right here. Okay, 5862. Right. Now I can list my running processes, and I think I won't. Oh, I do get something. Okay. These are my running processes right here. It says stopped though because I haven't given it any input. But I can actually, let's say I wanted to stop that program. I can actually send it the kill signal. If we man kill, sounds a little barbaric, I know, but all kill does is it sends a signal to a process. Okay. Now usually what you'll use is the -9 flag. So kill -9. Not -1 though. Kill -9-1 kills all processes you can kill, but it sends basically a terminate process to that. So if I do kill -9 5862, now do jobs, we can see that the cat process has been killed, right? And if I do jobs again, now it's not there anymore because it just notified me it had been terminated. Okay. So now let's go back to this thing. If I'm running this in the background, I can see that it's running. Okay. I've done what I needed to do. Now I want to see now I want to go back to that program. I can do FG, which is foreground. And now I'm back to that endless cat process, right? Now let's say I didn't want a keyboard interrupt it, but I just wanted to fork it into the background while it's running, right? I can do Control-Z, Control-Z. It will suspend that process, so we can see that it's stopped, right? So that means it's paused right now. So now I can say BG, which means run in the background. Okay. Now it's still stopped because I haven't given it any input. But if I look at my jobs now, cat is still running, right? Because I put it into the background. Okay. Now you can actually kill this without using its process ID. You can do kill and then %1. A little weird, I know, but that basically says, so you can see that this is numbered 1 right now. It just kills the first one in the table. So kill %1, it'll kill cat. So now if I do jobs, it's terminated. Okay. So that's kind of the basics of processes. There's a program that should be on all of your Linux systems called top. And this program it lists your process usage in real time, right? So we can see the columns there. The leftmost is PID, so the process ID of the process, and then the user that started the process. So we can see me, we can see root, and there's some other columns there that probably won't have to worry about for now, like that PR is the priority for the scheduler, NI is the niceness, virt is the virtual memory that it requested, res is the resident memory of the process, so how much it's actually taking up. And then you'll probably you'll probably look at the percent CPU and percent mem the most. That's the percent usage it's actually using. We can see, you know, PID 2133 is using like 41% of my CPU. That's my plasma shell. Okay. And then the right, the time plus, that's the time that it's been running. And then command is, of course, the command line that it ran with. Now, I would actually recommend, so top is really useful, but I would really highly recommend, if you are running Linux, to install this program called htop. I'm going to run htop here, and you'll see why. Much nicer output, and we get nice colors too, right? And we have a graphical representation of the usage. We can see up here is the usage of my. Where's my mouse at? Oh, it's on this side. Where is my mouse? There. We can see the like a graphical usage of each core of my processor, right? Percentages, and then we can even do. We have all these options down here. Like we can do that F6 sort by. So right now, we can see in the blue everything's being sorted by the percent memory, so percent RAM I'm using. We can actually change the. So I just hit F6 right now. I can change it to this percent CPU to sort by CPU usage. And now we can see the CPU percent is blue up here in the header, and it's now the process is using the most CPU is first. So it's like a terminal. It's like a terminal task manager, basically, right? Pretty cool. Okay. And then F10 to quit. Okay. Yeah. Any questions on processes? Kind of a quick gloss over of processes. All right. This is the final section, so yeah, thanks for bearing with me this far, okay? The package manager is very important in Linux because that's how you maintain software on your system, okay? Now, the cool thing about Linux is that Windows usually doesn't have natively, I should say, is when you want to update, you can update everything at once. Usually in Windows, you have to you have to run the program and then it asks you to update, or you download an update from the website and run that installer and installs over the other program. But with Linux, like I demonstrated with sudo apt-update and sudo apt-upgrade, you can update all of your packages at once, which is really useful, right? If you just want to update everything at once, you don't have to worry about broken packages and dependencies. The package manager handles the dependencies for you. It's very convenient. And the package manager pulls from repositories and verifies the package for you, right? So it verifies the integrity using, you know, cryptographic keys and all that. It does that for you, so you don't have to worry about getting a malicious package, right? A malicious piece of software. Okay. So I'm assuming all of you guys, when you're using Linux, are using an Ubuntu-based. I know you're trying to install Arch, which I can help you with. I actually much prefer Pacman over apt, but a lot of you guys are using probably Ubuntu-based, so I'm going to go over kind of apt. Apt stands for Advanced Packaging Toolkit. If we do man apt, man pat, can't type today. I did it again. Apt. There we go. All right. Apt provides a high-level command line interface for the package management system. It's intended as an end-user interface and enables some options better suited for interactive usage by default compared to more specialized apt tools like apt-get and apt-cache. Okay, we can see the man page numbers right there. So, yeah, so we have, we can see down here these commands right here. So update. And we can see this apt-get 8 is the underlying program that the update command uses. Some people actually run apt-get update, apt-get upgrade. I find it's easier to just use apt for everything because, one, it gives nicer output, and two, it's just it's easier to manage. So have you ever wondered what apt-update and apt-upgrade does? Well, we have the description in the man page. Okay, I'll sum it up for you. So update, basically, your Ubuntu keeps a list. So it has a list of links of where it needs to know where to download the packages from. The maintainer changes it and needs to know that. Okay, and it keeps a list of which versions of the packages to get. So when you do sudo apt update, all it does is it updates that list. to the most current version. So if you just did apt upgrade without doing apt update, you might pull some old versions of software. Now, I personally think it'd be better to just bundle it all up in one command like other package managers do, but this is the way that apt does it. So you do sudo apt update to pull the most recent versions and update that list, and then apt upgrade actually pulls them down and upgrades your packages for you. Okay. Full upgrade performs the function of upgrade, but will remove currently installed packages if this is needed to upgrade the system as a whole. So it kind of cleans the unnecessary dependencies that may get left behind if dependencies change in a package. Of course, there's apt install, remove, purge. Okay, so I guess I should probably run some of these. So we can do, I think we do an apt list. We'll list the packages. I think these are the ones that, oh yeah, I think these are the ones in the actual repositories. I think if we do apt-cache, apt-cache is like everything local. So I think we do apt-cache list. It'll, oh, maybe I should man this first, or help. Queries and displays available information about installed and installable packages. Okay, so we got some commands right there. So we can actually search packages on our system. I guess we can't list them, huh? Show a readable record for them. Oh, list the names of all packages in the system. PKG names. Okay. So I guess instead of list, it's just PKG names. Okay. So these are all the things that got installed. Now that looks like a nice format to grep. So say I wanted to look to see if I had a package on my system. I could do pipe that output to grep. And say I wanted to search for like GCC or something. Oh, I got a bunch of GCC packages on my system. So that's nice. Okay, yeah. So the main ones you really need to worry about are, apt update and apt upgrade. So upgrading steadily, and then apt install. So that's install, and then apt probably removing. So apt remove. Really, what I really do is I do apt remove -- purge, because it removes like configuration files and files that aren't directly related to the runtime of the program, which can be useful in like cleaning your system. Yeah, purge is also another command that'll actually, I think, do that for you. I go to the man page for apt. And Brinder here is probably the more knowledgeable on this than I am, because I'm actually not used to Ubuntu. I don't use it, but he could probably answer a lot of your questions. Oh yeah, see, we can see purge right there. Oops. Yeah, that's all I really had anyway. I really would just redirect you to the man page if you have any questions about your package manager, but I wanted to kind of get you basic knowledge of it, like, how to install, how to remove, how to update, importantly. So, oh, one thing I will say before I end this is adding a PPA, which is a personal package archive. How many of you know what PPAs are, or have heard of them? Okay. You can think of PPAs as, these are packages that are not in the officially supported repositories, but that users have put. Like if a user developed this cool project that they want people to be able to download to the package manager, they'll upload a PPA to Launchpad, which is where all the packages are stored. And the user will basically add a link to their list of repositories so that they can install that package and have it be managed by the package manager, so that when they release an update, the package manager will detect that and will install the update. So I think it's, yeah, so there's a tutorial for that, actually. I can post a link. Actually, I can probably just copy it. Yeah, that's what I'm, can't I click this? Oh, there we go. Give me a sec. So confusing. All right, and then that's why I don't use Ubuntu, my friends. Okay. Yeah, I'm just trying to pull up. So I can't even type in my thing. It's basically add-apt-repository, and then you type in the link. There's usually instructions online. I'm trying to pull it up, but this thing isn't behaving. So yeah, he'll do it. So while he's doing that, does anyone have any questions about anything that I've discussed? That's pretty much all I had. Cool. Oh, I think it just started responding. Oh, what the heck? Okay. Yeah. Anyway. Well, thank you for attending. He pulling that up here. Yeah, that's the link I was trying to do.
On literally any PPA will, if you scroll down here, it'll give you these commands. This is just the default in Launchpad. So yeah, you just run the command, run the other command, and then you run command to install the package, and you'll see down here there's the list of packages in the PPA. Yeah, it's pretty straightforward.
Yeah. Cool. Well, that's all I had for you guys, so thank you for coming. If you have any questions, I'd be more than happy to answer them afterwards, but otherwise, you guys are free to go. So, thanks for attending.